In this video, I'll show you how to write an algebraic expression without negative exponents. This is part 2 of the series. In the first question, we have the expression 2m squared n to the power of 3 x to the power of negative 2 all power to negative 3. To do this question successfully, you will need to know the following relationship, where if you have a term and there's a negative exponent, you can flip the base, take its reciprocal, then change the sign of the negative exponent. So that's what we'll do. We'll change this negative 3 into a positive 3 and take this whole thing, the base, as 1 over that base. Let's go ahead and do that. 1 over 2m squared n to the power of 3 x to the power of negative 2 all powered to 3. The next step is to distribute this 3 to every component within the brackets. 1 to the power of 3 still stays at 1. 2 to the power of 3 is 8. M to the power of 2 to the power of 3, you have to use the power of a power rule there. So 2 times 3 is 6. M to the power of 6. N to the power of 3 to the power of 3 is n to the power of 9. And x to the power of negative 2 times 3 is negative 6. That gives us x to the power of negative 6. Now the goal of this lesson is to show you how to write expressions without negative exponents. So we still have this as a problem, and we need to somehow change this negative 6 into a positive 6. All you do is you take your x, put it at the top, and change the negative 6 to a positive 6, where it becomes 1 times x to the power of 6, so x to the power of 6 over 8 m to the power of 6 n to the power of 9, and that expression right there is one written without negative exponents. Let's move on to question 2. In this question, we have two binomials being multiplied to each other. Remember, a binomial is an algebraic expression with two terms, and we have one here and we have one here. To do this, we have to multiply this term right here with the two terms in the other bracket. Then you add the product of this term multiplied to these two. Let me show you what I mean. So starting with p to the power of 2x times p to the power of negative 2, we end up with p to the power of 2 times p to the power of negative 2. We have to use the product rule here where we add 2 and negative 2. And if we do that, we end up with 0. So p to the power of 0 is equal to 1. The x, however, remains there. P to the power of 2x times this expression gives us negative p to the power of 2x, q to the power of negative 2, y to the power of 2. Let's move on to this term. Let's multiply this by the two terms. Negative q to the power of 2, y to the power of negative 2 multiplied by this term gives us negative q squared y to the power of negative 2, p to the power of negative 2. And this term multiplied to that term gives us a positive term because you have a negative multiplied to a negative. Q to the power of 2 times q to the power of negative 2, as discussed here, that gives us 1, so that goes away. And the two y's fit the same pattern. They go away too, so you end up with plus 1. Don't be tempted to write plus 0, because when I say they go away, I don't mean they disappear. I mean it goes to 1. So let's see if we can combine these. We can't combine these terms because they're not the same. Notice that we have a p to the power of 2 here and p to the power of negative 2. If they all had the same exponents and the same letters, then they're like terms and they can be added. But that's not the case. What we have to do next is to convert the negative exponents found in these two terms so that they're positive. Here's how to do that. X minus p to the power of 2 x y to the power of 2. Notice that this component, and that component remained at the top, and at the bottom of this term we'll write down q to the power of 2. Similarly, minus q to the power of 2 will be at the top, and at the bottom we'll have y to the power of 2 and p to the power of 2 plus 1. This expression that we have here is an expanded version of the expression we started with without any negative exponents. And so there you have it. Two more examples on how to write an algebraic expression without negative exponents. Make sure to watch part 3 for some more challenging examples.